Hello students, in my previous video you have seen there are so many ways through which we can create a data frame. Now let's continue the creating of data frame. So here you can create a data frame using dictionary also. So you can see the example here, data equal to within curly brackets, that means it is a dictionary. Inside this, name is a key and the values are given in the form of list. So here name of the students are written, IP score, ACC score, business studies, English and economics. And once the data is ready, we are creating a data frame by using data frame function. So pd.dataFrame and within bracket data. Let's see how the data is created. In this example, set of values are given, and now if I run this program, see the output here. Now here data frame is created and the values better you can see in this way if I increase the size of the output. So you can see here the column name, IP, accountancy, business studies, English and economics, and here indexes are 0, 1, 2, 3. So here once the data is stored in this format, this data can be accessed in different ways. In this example, the index is created automatically and they are 0, 1, 2, 3. But if I want to change these indexes, then Python provides a facility we can change it. Let's see. Here the syntax is you are familiar with data frame variable name you can define equal to pd python pandas dot data frame, and you provide the data, and here one parameter will be index equal to, and then you can provide the list of indexes what you want, and this can be given here within this bracket. So you can use, you are providing list of values, so you can write here like this. Now let's see how it works. Here I am defining indexes as their admission number. Say it is B1, B2, B3 and B4, and let's see what are the indexes. So now here the same data frame is coming, but this time instead of 0, 1, 2, 3, here it is coming B1, B2, B3, B4. So with this example, we understood that indexes can be changed as per our requirement. We can create data frame from 2D dictionary also. Now let us see the example here. One dictionary is for year 2015, one dictionary for 2016, one for 2017. And then I'm defining here sale 2015 and data is taken from this dictionary. So here I'm defining 2015 and year 2015, then here you can say 2016, and then I'm using here 2017. So once this dictionary is ready, then we can define here data frame and we can define the cells month wise. Now let's see in Python ID how it works. Now you can see the same example has been typed here, and year wise cells are stored here month wise. So here it is year 2015, 16, 17, and month is here January, February and March, right, for 3 months. Now once the data frame is ready, let us see how the data frame is created and how the data is organized. So here you can see here February, January, March, because it is dictionary, so order can be changed automatically by Python. And here instead of 0, 1, 2, here the February, January, March are the indexes here. And year wise column it is creating 2015, 16 and 17, and these are the cells or items sold for a particular item. Another way of defining data frame using 2D array, let us see. Here I am defining a variable array1 equal to np.array and providing two-dimensional array here. The first row is 1, 2, 3. Second row is 7, 8, 9. So here it is 2 into 3 matrix I am defining here. 2 rows and 3 columns. The type is integer 32 and then creating a data frame. Let's see in Python ID how it works. So here I have typed a program array and then creating the data frame. Let's run this program to see the output. Now see here there are 2 rows and 3 columns, and the value the first row is having 1, 2 and 3, and second is having 7, 8 and 9. So using 2D array we can define data frame. Now to specify a column name, we can use the column name property here, columns equal to, then we can provide the list of values. Now here I am providing the column names instead of 0, 1, 2. Here I am writing columns equal to 1, 2 and 3. Now let's run this program and you can see the output is here. The column is 1, 2 and 3. So it can be defined by using columns. You know by default index are 0, 1, 2 like this it goes. So if you want to change the indexes here as per your requirement, like for example here I am writing index equal to A, B, C. So this way we can change the index of the data frame. Now here instead of row 0 and 1 I am writing here index equal to row 1 and row 2. Let's run this program and see how it appears in a data frame. So now you can see here this time we have defined both. The columns are defined as 1, 2 and 3 and instead of 0 and 1 as index it is coming row 1 and row 2. Once a data frame is ready, we can create another object or another data frame by using existing data frame. Like here df1 is already available and I want identical of df1 as df2. So I'll write here df2 equal to pd dot data frame within bracket df1. Now let us modify the previous data. So here I am writing here df2 is equal to pd dot data frame within bracket df1, so that df1 and df2 should be identical. So after creating df2 I am writing here print df2 to print the content of df2 to see. Let us see here whether they are identical or not. So if you run this, here you can see this is df1, the content of df1, this is the content of df2 and both are identical. So one data frame can be created by using another data frame. I'll be talking about the data frame attributes and I'll demonstrate one by one. Now let's see here index is one attribute, then columns, then axis, then dtype, then size, then shape, then values, then empty, then and dimension dim, and T for transposing index and column. So these attributes, how they can be used and what is the meaning of it, I'll demonstrate by using Python IDE. To demonstrate the use of attributes of data frame, I have created here one data frame. Let's see the data frame. It contains name, IP, accountancy, business studies, English and economics marks of 4 students here, and the indexes are 0, 1, 2, 3. If I want to know the information about the index, if I just write index, it will give me the details of index of data frame. Now you can see here the range index is starting from 0, stopping at 4 and the step is 1. The attribute column is used to find the column index of a table. So you can see here if I run this program, you can see here the index for the column is the name, IP, ACC, business studies, English, economics and data type is object. Now let us see the use of axis. Here I am writing df1.axis and if I run this program it is showing you here the range and what are the indexes x0, x0 and x1. So you can see here the name here, name, IP, accountancy, business studies, these are the indexes here and the end range is here. Range index is starting from 0, stopping at 4, step is 1. Here dtype function returns the data type. Let's see the output here. Now you can see here this attribute is returning data type. Object has no attributes dtype, or you can say here it should be dtypes. So let us run the program again and here it is data type. Now you can see here the IP marks, IP, accountancy, business studies, English and economics are of integer 64 bits and the name is object because it is a collection of characters. Right here df1 dot size and here it is displaying 64. So total number of bytes which are used for storing this object is 24 bytes. Now we can use the shape function df1.shape, and if you return here 4 into 6, that means there are 6 columns and 4 rows. Now to confirm this, we can print the data frame, and you can see here 1, 2, 3, 4, 5, 6. So there are 6 columns and 4 rows here, 1, 2, 3, 4. Another attribute is values. So if I apply here df1.values, it returns the numpy representation of the data. So you can see from here there is a list inside another list, and one list is used for one student, another list is used for another student, and finally it is nesting of list. So numpy representation will look like this. Here empty attribute is used to check whether the data frame is empty or not. Let's see this. Here this is not empty because we have provided the data, so empty returns false. Endim attribute returns the number of x's. Now you can see here the number of x's, there are 2. Now let us see here, print the data frame. The original data frame is looking like this. There is one attribute T is for transposing a matrix here. So data frame can be transposed. So in that case row becomes column and column becomes row. So let's run this program and see how it is transposing. Now you can see here name is coming here, that was the actually row here, now it becomes column, and these marks were earlier, this was IP was one column, accountancy was one column, now here it becomes row. So row and column are transposed.